Okay, so the last thing with functions right now that we're going to talk about is something known as function notation. Consider the equation y equals 2x plus 3. We might say, hey, find y when x is equal to 4. So we'd go through the process to say, okay, we replace x with 4, right, and simplify. And we find out that y is equal to 11. Now, problem with that answer there is we know y is 11. But why is y equal to 11? Y is equal to 11 because x was equal to 4. And so one way to kind of recover that is to write down your answer as a point, the point 4, 11. And then it's really clear that the y value of 11 is tied to the x value of 4. And so we introduce a notation that kind of combines those two ideas of an equation and a point and puts them together. And that's what function notation does. Now, there are lots of other reasons for this function notation that come up in courses beyond this one. For our purposes, it's really just a combination of the point and equation notations. We're putting them together. It's a different way of writing an equation. It's also a way of writing an equation that gives some students a little bit of trouble. And so we're going to take a little bit of time and go over how it works. So instead of writing y equals 2x plus 3, we use a function. Typically, the typical letters are f, g, and h, although you could write this as y parentheses x. And instead of writing the point 4, 11, we would say f parentheses 4 equals 11. Now that f parentheses x is read f of x. So f parentheses 4 would be read f of 4 equals 11. Okay, what it is not doing is not saying multiplication. Okay, the parentheses there are used to tell us the variable that f depends upon. Okay, function notation is kind of emphasizing this dependency. And if you kind of go back to our idea of a function in terms of a graph or in terms of ordered pairs, right, it's saying that value, go back to the supermarket analogy, that barcode is that price. So scan the barcode, get that price. So f of x. And so when you see f parentheses 4 equals 11, that would be saying f of barcode 4 cost $11. So the cost for that is $11. Okay, but it does not mean multiplication, which is one of the most common mistakes that people make. So f of 4 equals 11 means that f is equal to 11. We don't divide by 4. The 4 is there just to remind us in the equation notation that the reason that f is 11 is because x is equal to 4. Okay, that's all that 4 is telling us. It's telling us the x values that causes f to be 11. Or in a supermarket, it's the barcode that led to that price of $11. Okay, so that's the idea of function notation and how it works. To kind of help you understand it a little bit better, let's consider some examples. Here we have a polynomial function, f of x equals 2x squared plus 5x minus 6. And let's say we want to compute f of 3. Okay, to evaluate a function, I encourage you to do the following. Write it down as blank. F blank equals, and then everywhere you see the variable, replace that with a blank. Replace that with a blank. And then you can just go through and say we want to do f of 3, so that would be a 3 there. And every blank gets filled in with a 3. A lot of people get a little trouble with evaluating a function sometimes when they first encounter it. I think by doing this, writing it down as blanks, and think of it as just filling in the blanks. And now you can forget about it being a function for a moment and just work on evaluating this stuff that's left over. So we simplify. 2 times 3 squared. 3 squared would be 9. 2 times 9 would be 18. And then plus 5 times 3. 5 times 3 would be 15. And then minus 6. and then we just simplify. And so 18 plus 15 is 33, minus 6 is 27. So f of 3 is 27. We do not divide by the 3 again. The 3 is there to tell us the x value that caused f to be 27. So very important. One of the most common mistakes is to try to divide by that x value. So as another example, let's say we want to figure out when f is equal to negative 6. Okay, again, the notation, f parentheses x, the parentheses there with the x is telling us that f depends on the x value. When we go in and replace f with negative 6, we're actually going to replace that whole parentheses thing, f parentheses thing, with negative 6. Because f is taking the place of y. So if you're replacing y with negative 6, then it would just be negative 6 equals. So when we have f as negative 6, we're going to replace the whole f of x with negative 6. We then have an equation that we can proceed to solve. It's a polynomial equation. So we want to get it equal to 0. So I take that negative 6 on the left-hand side, add it to both sides. And when I do, I get 0 equals 2x squared plus 5x. As a little test to yourself, you might want to try to solve that equation. We can do so by factoring out an x. We have x and 2x plus 5. So one of those two things must be 0. So that leads us to x equals 0, or 2x plus 5 equals 0. Solving those two equations gives us x is 0 and negative 5 halves. So there's actually two x values here that lead to an f value of negative 6. And here we have a fractional function. F of x is equal to 2 plus 3x over 4 plus x. And let's say we want to evaluate when f is 2. Again, my advice is to write down the equation with blanks everywhere you see an x. And then you're just going to fill in the blanks with that number. It's f of 2, so each blank gets replaced with a 2. Okay, we then would go through and just simplify in the top. 3 times 2 is 6. 6 plus 2 is 8. In the bottom, 4 plus 2 is 6. So we get 8 over 6, which we can simplify to be 4/3. Okay, as another example, let's say we want to do f of negative 3. Again, write it down so that the variable has been replaced by blanks. And then for every one of those blanks, just plug in your x value, in this case negative 3. Okay, so get 2 plus 3 times negative 3 over 4 plus negative 3. The numerator, 2 plus 3 times negative 3 would be 2 minus 9, would be negative 7. The bottom, 4 plus a negative 3, 4 minus 3 would be, oops, I made a mistake. That should just be positive 1. And then finally, my answer should be negative 7. So negative 7 over positive 1 would be negative 7. Okay? And so that's evaluating a function using function notation.